This is Glenn Tan speaking. This time, I'm going to talk about VERSATI3, the installation. And here I'd like to emphasize that this presentation is based on the China standard. And if you have a higher level or you have a local code to follow, please follow your local code because this is the basic requirement. This presentation divided into these three parts. For the next chapter, we will go to the water system installation. Also, in the system diagram, it is this one, this part is all the water system, including the water tank, FCU, radiator, or the flow coils. These are the components you should use during water system installation, including water filter for the indoor unit, especially for the hydro box, two-way valve, three-way valve. This three-way valve is only for monoblock. As for split type and all-in-one, there is already a built-in three-way valve inside. Bypass valve, this is for the FCU, and flow coil performer, piping and the joints for the water system, and also a cut-off valve. Inside the water system, the most important component is the water pump. And here I just offer you a calculation to how to select the water pump, and which is according to this formula, and which is according to the outer unit capacity, and also this delta T. This means the water in and out temperature difference. Basically, is from 5 to 7. We recommend 5 degrees. And after that, we will offer you this water pump graph. And from this one, you can do the calculation. A little bit complicated, and I will show you a detailed example. So in this case, there is a 10 kilowatt monoblock NHG series, the outer unit, which inside the outer unit, the pressure drop, you already texted, is 60 kPa. And on the water system, you check it, and also the value, which is the pressure drop, is 90 Pa. So the question is, do you require the additional water pump? Why we need additional water pump? That is, although we have a built-in water pump, but according to your actual project, it is not enough, especially for the external head of delivery. If it is higher than the built-in, the maximum, also you need to apply an additional water pump. And here is how to do the calculation. First is follow this formula. You can get the rated flow rate to beat this one, 1.72. And then according on this graph, 1.72 is here. Then you can get the available external head of delivery is about 4 meters, which is about 40 kPa, right? And also just compare this 40 kPa with the water system pressure drop 90 kPa, which is less than that. So our conclusion is you need the additional water pump. And also just pay attention that this 90 kPa is only for the water system. And what you have measured, the 60 kPa, is actually already inside this diagram. No need to use this one. Next, we'll go to select the water tank volume, and which is this QD. And this QD is according to where you install, either on the house or on the villa. You can find it. It's for daily water consumption for every person. For each day is different. And also how to use it, either with a bathtub or not, or it's only for the shower, also different. So this QT is the summary of all this one. After that, you need to make a correction to get the final V10, which is for the water tank volume. And here I just take it this alpha, just this value, which is how long you will take the shower and for each person. This slide displays how to install the water tank. First is the distance requirement from the indoor unit, horizontal 5 meters, vertical within 3 meters. And also depending on your water system pressure, which is this 3, basically you need to make sure the water system inside the DHW, which is the water tank, it should be at this range. If lower than that, you need to apply the check valve. And if it's higher than this, you need to use a regulator to lower the pressure to this range. And as for the installation, basically this water tank should on the ground because it is too heavy and also not suspended. Also, no cut-off valve between the water tank and the safety valve to ensure the water system reliable. This slide displays the requirement for the all-in-one indoor unit installation. And basically, this part is similar to previous, which is for installation. Also, it is heavy, so no suspended directly on the ground of this one. And the next is to install the water makeup pipe and also the remove the air. Just follow this step 1 and step 2 to do it. It's okay. And also you can find it on this all-in-one series. Here is the DHW out, and this is to the space heating or supply water. And this is back from the heating water, and this is the tap water. And the requirement for the tap water also this one, which is also need to ensure the water system pressure to be this range. And lower than that, apply the check valve. Higher than that, apply the regulator. Also, here is air release valve. This is to help you to do the air remove. As for the water tank, you can also buy from your local market, which means you don't need to buy from our grid. And if you choose from our grid, we can offer you this model. And from here, you can find that there are 2 coils inside, and also the built-in heater. It is a single phases, and enamel here is the size. Also, for 2 coils, you can apply another coil with the solar panel, which is to higher the water heating efficiency. As for the fan coil unit, you can choose also from our grid or buy from your local market. It's fine. And we recommend the capacity of this FCU is from 70% to 120% of the outdoor unit capacity. This slide displays the requirements for the flow coil. And to install the flow coil, basically you can have these 2 choices. One is the counter flow, which is the flow coil is we just make it like this structure, and the serpentine structure, which is like this. Also, here is the comparison between these 2. We recommend this method. As for how to install the flow coil performer, which is to distribute the hot water to the flow coil, here is the requirement. And basically, is this one, you can find this connected to the indoor unit or the all-in-one. So we need to divide the hot water to different flow coil. Basically, this flow coil should be at the same level. So for this case, we divide it from here to different coils in 2 levels is not correct. And it should follow this one, which is divided from here, not from the flow heating or flow coil performer. As for the distance between the indoor unit, which is the water pump, to the performer or the manifold, it should be within 15 meters. If it is more than 20 meters, you need to do the water system calculation again. For the flow coil performer or water check or the collector, here is the requirements. Basically, it should be this higher than 300 meters, or you can follow your local code. And also, the water supply should be at the upper side, and also equipped with a filter. Here is the pipe in and the pipe water out. Next is for the expansion tank in the water system. Here we call it expansion cell because it is a small size, and we already have the built-in for monoblock and the split tie. And for this part, the preset pressure for the monoblock, it is 1.5 bar. And according to your water system size, you can adjust for this one. Which means we offer you these 2 diagrams, and according to your water system volume, you can select or to double check whether the built-in expansion cell is enough for you or not. The calculation should follow this formula to adjust the preset value, especially for the monoblock series, which is adjusted by the nitrogen gas. And this H means the height drop from the indoor unit to the highest spot of the water system. And this PG is the inside pressure. Actually, it's a little bit complicated. We just make a table for you to do this one, which is according to your water system size, which is the water system volume. If it is less than, for example, the 10, 12, 14, and 16 kilowatt, these 4 series, these 4 unit, if it is less than 66 liter, and the height drop between the indoor unit and the highest point of the water system, it will divide it. Also, you can follow this part to do the calculation and change the inside pressure. Is okay. A little bit complicated, right? So I also show you a detailed example for this part. So in this example, it is 16 kilowatt monoblock NHG series installed in a 5 meter lower than the highest point of the water system. And also the total water volume is 60 liter. And according to this table, which is you become to this one, which means no need to adjust. So for the case 2, for also 16 kilowatt monoblock NHG, and this time is only 1 meter lower, and the water volume is 100 liter. So we become to this part, which is adjust to above formula to adjust the preset pressure, and also check whether this water volume is less than the maximum, which is this one. And according to this formula, you can get it is you need to make it to be 0.4 bar. And also from this graph, first to locate it, where is the 0.4 bar, and it's here, and then you can get the maximum water volume. It will be this value. It is higher than the 100, so that means okay. And the step 3 is adjust the inside the expansion valve cell the pressure from 1.5 to 0.4 bar, and all finish. As for the expansion valve cell for split and all-in-one series, it is similar and also the same formula. And also from this one, we offer you this table according to your system situation, which is the height drop and also the total water volume. You can get the detail. Either you need to adjust the volume or not. Also, show you a detailed example to explain. Case 1, 10 kilowatt split tie. The indoor unit is 5 meters lower than the height spot of the water system, and the water volume is 200 liters, quite large, right? So this time, also in here, the answer is no need to adjust. And for the case 2, also 10 kilo split, and the indoor unit this time is 4.5 meter lower than the height spot of the water system. The total volume is 250. So inside this table, we come to this part, which is according to this formula, you can get the pressure to be this one. And then step 2 is to check whether under this 0.75 bar, the max water volume. It can support max 325 liter, which is less than your actual 250 liter. And the step 4 is adjust the inside pressure from 1 bar to 0.75 bar is okay. Next is to choose the best water volume. As you know that if the water system or the water volume is too small, it will just make the temperature or the water temperature to fluctuate too much, which means it can reach the set point quickly, and also it will lose the power or lose the capacity quickly, which means the customer will complain that why the indoor room temperature is it fluctuates so quickly. On the other hand, if the water system is too large, it will also cost too much power for the heat pump to heating up or cooling down the water. And what you can apply is the buffer tank. Inside the water system, here is the experimental calculation. Just for your reference, what is the minimum water volume according to your outdoor unit or the heat pump capacity? Also follow this formula, you can get the water volume. And here is just offer you the information for different size of the water piping and how many or how much water volume from 1 meter. For the water piping, we recommend to adopt the hot melt connection to install the PPR water supply pipes and also the fittings. And here is the fittings and also the corner and the piping. And how to do it is just follow this video. It's quite easy. And here is how to make the fitting and the pipes together with the hot melt connection. You can find it just a hot melt, just like this one is okay. No need any other complicated wiring or the connection. After you install the water system, the next step is to charge the water and also make the air to remove from the water system. And at that time, we offer you this air remove at the controller. You can choose which is to control this three-way valve and also turn on the built-in water pump, this one, to make the water to be circulate, to remove the air either in the air conditioning system, which is at this part, or on the water tank,